Hey there, it's Mr. Alexander. Today I'm going to talk about solving exponential equations, like this one right here. 6 to the x minus 5 power equals 24. There's essentially two methods that I like to use to solve these. I'm going to show you both methods, and I'm going to let you decide which one you like better. The first method is trying to cancel out this base here. So since the base of this exponential expression is a 6, I'm going to take the log base 6 of both sides. Remember, there's only one rule in algebra that matters. Whatever you do to one side, you'd better do to the other side. And the reason that I took the log base 6 of both sides is because this log base 6 and that 6 on the base of the exponential, they just cancel out, which leaves me with x minus 5 equals the log base 6 of 24. I hope you'll agree that it'd be pretty hard to type in the log base 6 into your calculator without the change of base rule. So I'm actually going to change this into so that both of them are in base 10 here. So log of 24 divided by log of 6. That's something you can type into your calculator. Don't have a log base 6 button, but we do have a log base 10 button. So I'm going to do that real quick. I'm just going to type it in. Log 24 divided by log 6, and I'm going to round it off to the nearest thousandths. So I'm going to write down 1.774. So x minus 5 equals 1.774. And that should actually be kind of a not a straight equal sign. It's approximately that because we rounded. To get x, then, we're simply going to add 5 to both sides to get 6.774, which is our answer. So throughout the course of this video, I'll be rounding to 3 decimal places to the nearest thousandth. So that's method 1. That's one that I like, but the method I prefer is actually method 2, and I'm going to show you method 2 on the second question here. So I've got 12 to the power of x plus 4 equals 65. In method 2, we essentially ignore whatever the base is. We say we don't care, and we just take the log base 10 of both sides. You might be asking me, why, oh why did you do that when this log doesn't cancel out that 12? Well, that's fine, but what it does do is, remember your exponent rules, we can take this exponent right here and we can move it out front. That's the nice thing about logarithms. So I've got this x plus 4 times log of 12 equals log of 65. So now we don't have an exponent anymore, so I can just go ahead and divide that log of 12 over to the other side. So I've got x plus 4 equals log 65 over log 12. And at this point, I'll go ahead and type that in the calculator. Log 65 divided by log 12. That's approximately 1.6, and now that's going to round up to 1.68. So x plus 4 equals 1.68. And again, I should use those approximately equals since I rounded. And then x is, and I keep doing that, about approximately, and now when you subtract 4 from that, you've got negative 2.32. Now the reason I'm not plugging these back in is because, well, there's nothing that could happen here to make it extraneous for one thing, but when you plug it in, let's go ahead and do it on this one. 12 to the power of negative 2.32 plus 4. You'll see that it's not exactly 65, and that's a matter of us rounding. So if you were to give the exact solution, you would write log 65 divided by log 12 minus 4. Okay? So that's method 2, which is my preferred method, which is the method I'm going to use from here on out. So here we're trying to, we've got negative 8 times 2 to the power of x minus 9 minus 5 equals negative 77. I'm going to go ahead and add 5 both sides first. And that's going to give me negative 72. Then I'm going to divide by negative 8 on both sides to get 2 to the power of x minus 9 equals 9. And since I prefer method 2, I'm going to go ahead and take the log of both sides. I'm going to write log 2 to the x minus 9 equals log 9. Can bring that exponent over. So I've got x minus 9 times log 2 equals log 9. And then I'll divide by log 2 on both sides to get x minus 9 equals log 9 divided by log 2. Now on this one, instead of going ahead and doing that calculation, let's get the exact answer first and then approximate it, because it's actually a better idea to round at the very last step instead of the second to last step like I did in the first two problems. So the exact answer is x equals log 9 divided by log 2 plus 9. So that's the exact answer, and now we should approximate it now that we're at the last step here. So now I'll type it in. Log 9 divided by log 2, and I'll add 9 to that to get, it's about 12.17 when you round that to 3 decimal places. 12.17. Again, if I plugged that back in, I wouldn't get exactly negative 77, but if I plugged this entire thing in for x, then I'd get exactly negative 77. Alright, so let's do a couple more here. I've got 8 times 5 over 8 to the 4x power equals 448. First thing we ought to do here is divide by 8. So 5 over 8 to the 4x power equals 56. And now that there's nothing in front of the base here, I can go ahead and take the log of both sides. So log 5/8 4x equals log base 10 of 56. Alright, we can bring the exponent out front, so I've got 4x times log of 5/8 equals log 56. I'll divide both sides by log 5/8, so I've got 4x equals log 56 divided by log 5/8. And then the last step here is to divide everything by 4, so the exact answer is x equals log 56 divided by log 5/8, and that whole thing is going to be divided by 4. So when we approximate that in the calculator, we'll do log 56 divided by log 5/8, and we'll divide that whole thing by 4 to get approximately negative 2.141. Alright, so that's it. That's basically how you solve logarithms. Let me just show you one thing. I just want to prove to you on a relatively simple problem that the two methods I've shown you in this video are the same. You get the same answer. So let's do method 1 over here, and we'll do method 2 over here. So method 1, you'll remember, is you take the log of the base of the exponentials to both sides. So I'm going to do log base 11 of 11 to the x minus 4 equals 343. And then, of course, and I forgot the only rule in algebra that matters, which is whatever you do to one side, you better do to the other side. So that would be log base 11 of 343. Now here, these will cancel out, leaving us with x minus 4 equals log base 11 of 343. I can't type that directly in the calculator because I don't have a log base 11 button. But what I can type in the calculator is the change of base rule, log base 10 of 343 divided by log base 10 of 11. And so the exact answer here is log 343 divided by log 11 plus 4. And you can type that in the calculator, but for the purpose of this exercise, it's not important to know what the approximate answer is. I just want to show you that we get the same answer using method 2. So in method 2, instead of taking log base 11, we simply took the log of base 10 of both sides. Now when you do that, you can bring the exponent out front, and you've got x minus 4 times log 11 equals log 343. Divide both sides by log 11, you've got log 343 divided by log 11. And then of course the exact answer is x equals log 343 divided by log 11, and then we'll add the 4. Hopefully you see that the two methods yield the exact same answer. The only difference is method 2, it gives you an extra step in there that you don't have in method 1. So you might be wondering why I prefer method 2. Well, I just like this better because I've got a log base 10 button in my calculator. I don't have to remember any weird rules about change of base. This is just easy algebra. Just take the log of both sides, go from there. So that's why it's my preferred method. But you can see that you get the same answer no matter what. So you pick the method that works best for you. Thanks for watching. We'll see you next time.